Greetings of the day, dear students. In this video, we are going to discuss about EMF equation of generator. We will see the final equation EMF generated Eg equals to 5Z NP by 60A, and also we will discuss one example on this topic. Clear? Right. Now, coming to the EMF equation of generator, let me consider P, the number of poles of a machine, magnetic poles, where we are having alternate north and south poles. Let P be the number of poles of a machine, right? And phi, the flux per pole, which is expressed in Weber, and Z, total number of armature conductors which are present in the armature in the slots. Let Z be the total number of armature conductors, and N, the speed of armature revolutions in RPM, revolutions per minute, RPM. And one more important point, A, which indicates the number of parallel paths in the armature winding. As we have discussed previously, the armature consists of the slots. In those slots, this armature winding will be running, right? Now, depending upon the type of the winding, whether it is wave winding or lap winding, right, the number of parallel paths will depend. If it is wave winding, the number of parallel paths will be equal to 2. If the winding type is lap winding, the number of parallel paths will be equal to the number of poles P. And while attending the problems, while doing the problems, he will specify you in the problem which type of winding the machine is having. So depending upon that, we can decide whether the value of A is equal to 2 or A equal to P, right? So these are the variables we will be having in this equation, in the derivation of this equation. P indicates the poles, 5 flux, number of armature conductors, N speed, A number of parallel paths. Now, by the time the conductor completes one revolution, obviously it will pass through P number of poles. Here, phi indicates the flux per pole. Obviously, by the time it completes one revolution, the flux cut by conductor, the flux cut by one conductor will be equals to the P phi, where phi is the flux per pole and P indicates the number of poles, right? Yeah. Now we have considered the speed n in RPM. For example, if it is making 1500 revolutions in 1 minute, that is in a span of 60 seconds, then time taken for one revolution will be how much? Time taken for one revolution will be obviously 60 divided by 1500 RPM. So here, if we consider the time taken to complete one revolution, it is simply given by 60 divided by the speed in RPM. Here, clear? This is the time taken to complete just one revolution. First, we will do all the calculations for how much voltage is induced in one revolution by the time it completes one revolution for one conductor, right? Now the average induced EMF is given by P phi by T, where P phi indicates what is the flux cut by the conductor and T indicates the time taken for one revolution. This is important, P phi by T. If we substitute T equals to 60 by N, then in average induced EMF E is given by 5 NP by 60. Clear? And all these things are happening for one conductor. Keep in mind, all these things are happening for one conductor. Now depending upon the winding type, right, and it will decide the number of parallel paths. For example, let me tell you here, for example, if you are having some 6 resistors, if I say, let me consider some 6 resistors we are having. If I say 3 parallel paths, then in each parallel path, how many resistors will be there? 2, obviously, right? How we can draw that? For example, this is one parallel path R1, R2, and this is one more parallel path. Two resistors we are having, because we have to accommodate 6 resistors in 3 parallel paths. Then obviously in each parallel path, how many resistors are there in series? 2 resistors are there in series. If there is a voltage drop of V1 across first resistor and V2 across second resistor, the total voltage drop in series connection, it will be V1 plus V2. Similarly, the generated voltage also, for example, across all the parallel paths, the voltage will be same, right? So if we know the voltage induced in one parallel path, then in parallel connection the voltage will be same. So across all those parallel paths the voltage will be same, right? Here also the total number of conductors are Z. Obviously the number of parallel paths are A. Then how many conductors will be in series? That is important. Z divided by A. Very, very important. Z divided by A. Number of conductors are in series. Right? Now, as these many conductors are in series, across each conductor we know the induced EMF. Now across entire path the induced EMF will be how much? Very simple, very, very important. Across entire series path the induced EMF will be P phi n by 60 into Z by A. Understood? Right. So based on this, E equals to phi Z NP by 60A, where phi indicates the flux, Z indicates the number of conductors, N indicates the speed in RPM, P number of poles, A number of parallel paths. Right. Now if the machine, the same DC machine, if it is a generator, this induced EMF we will denote with the letter EG. EG, generated EMF or induced EMF, EG. If the same machine is working as a motor, right? Now this induced EMF is called back EMF, EB, denoted with the letter EB. EB indicates the back EMF, EG indicates the generated EMF. In both the cases, the thing is same, 5Z by 60A, right? So this is how we can calculate the generated EMF. Now let me do a small example on this so that we can understand it in a better manner. A 8 pole lap connected armature of a DC machine has 960 conductors, a flux of 40 milliweber, and the speed 400 rpm. Then calculate the EMF generated, right? And also if the same setup is having wave connected winding, then at what speed these conductors must be driven to generate a voltage of 400 volts. Clear? Now first let me write down the data given. The thing is simply asking the generated EMF, EG. For that we know the formula, EG equals to 5Z by 60A. While attempting this question, right, for all the numericals the exact variable name is to be known, otherwise it will be very difficult to do the substitutions. For example, the moment we see here 8 pole, then it should come to your mind the number of poles, P equal to 8, it is denoted with the letter P. The moment you see here he has told you 960 conductors, then it should strike out to your mind the number of conductors are denoted with the letter Z. So Z, number of conductors Z equals to 960, and flux per pole he has written a flux of 40 milliweber. So phi equals to 40 milliweber, phi equal to 40 milliweber per pole, and the speed in RPM 400 RPM. And the key point to decide the number of parallel paths is winding type. He has specified in the problem lap winding from the basics we have learned, if the winding is lap winding, the number of parallel paths will be equal to A equal to P, number of poles. So obviously the value of A is equal to 8. Now in this formula, the generated EMF Eg equal to 5Z NP by 60A, phi equal to, the common mistake most of the students are going to commit is directly they will write 40, but he has specified here clearly 40 milliweber. So you have to substitute 40 into 10 power minus 3, right? So that is what we have done here. 40 into 10 power minus 3 into 960 into 400 into 8 divided by 60 into 8. So total we are getting 256 volts from the generator. Clear? Right. Now if the same machine is having wave winding, in the wave winding from our basics we know the number of parallel paths will be equal to 2. It does not depend upon the number of poles in a machine. It is simply A equal to 2. The number of parallel paths will be equal to 2. Right? Now we know Eg equal to 5Z NP by 60A. He is asking that what should be this speed such that the voltage generated must be equal to 400 volts. Then obviously N equal to Eg into 60 into A divided by 5ZP. Therefore Eg 400 volts is to be generated, right? 60 into number of parallel paths are 2 divided by flux is same 40 into 10 power minus 3. Conductors are not changed, number of conductors are same 960, number of poles are also same 8. Therefore if you are able to rotate the machine at 156.25 rpm, then you are going to get, we are going to generate a voltage of 400 volts, a voltage of 400 volts. Clear? So this is what all about the EMF equation of a generator. In this entire discussions, dear students, please observe the terminology. Variables are important. Variables are important. Variables. P indicates poles, phi indicates flux, N indicates speed. Sorry, N indicates speed. A number of parallel paths. If lap winding A equal to P. If wave winding A equal to 2. Flux cut by one conductor P5. Time taken 1 for 1 revolution 60 by N. This point is important. EMF induced E equals to P5 by T, and depending upon the number of parallel paths, how you can get that? Z divided by A gives the number of parallel paths. If you have a doubt, think like this. If you are having 6 resistors and if you are having 3 parallel paths, how many conductors will be there in each parallel path? 6 divided by 3, 2 resistors will be there in series, right? Now in parallel connection voltage will be same. If you know the voltage across one parallel path, we can get the total voltage will be same across each parallel path, right? So this is the voltage across each parallel path. Z by A, P phi N by 60 to Z by A, right? So these are the points to be highlighted while attempting a question from this topic, right? Thank you.